Yes, we come back to trigonometry, and this is about true variance. Make sure you watch the previous video where I explain how the true variant works. So I gave several examples, and actually you can have a look here. So we start from definition what variance is, how to find the course. If you have the starting point A and your, let's say, ship or boat or airplane, so actually moving towards B, so B is the final point, so make sure you watch that. And actually below I gave several examples how to find the distance. So the shortest distance basically from the original position if your object is traveling in different routes, I mean different segments and different courses. Okay, so today we're gonna go through examples, and that's the first problem where we're going to find all the bearings, or yeah, in this case we need to find all the bearings for different points. So you have several questions. Try to pause the video if you can do by your own. So grab a pen, grab notes, and let's start doing together. All right, so what we have that 3 points A, E, B, and C right there, basically vertices of the triangle within proper bearings. Okay, so we have 128 degrees, 256, and 20 degrees. So bearings, I just remind you that bearings is the angle measured in clockwise direction, and it's measured from the north direction as the reference one to your course. Okay, so for example here 128 is actually the bearings C from B, and we already know, like, we can answer some questions definitely. All right, so let's have a look. So the first one, we need to find the bearings B from E. So here is the point B, and here is the point E. Okay, so make sure you remember that the bearings, when you consider 2 points, make sure you set up north direction and the point E, because right now you're going to move in the point B. So B is the final point where you need to go. So that's why you're setting up north direction right there in the point E. This is your reference direction, and then you measure, or basically have a look at the angle in the clockwise direction until you reach the segment EB, because your B is the final point. So you just turning 20 degrees, as you can see here. So the answer is 20 degrees. It's already done. Okay, let's have a look at B. So C from B. So we got the point C, and we got the initial point B where it's actually staying. So that's why we need to set up north direction exactly in the point at the point B, and make a turn again until you reach the segment BC. Alright, so it's already done. It's 128 degrees. So that's why the bearings is going to be 128 degrees. Alright, so I hope it's pretty clear. Okay, so let's go to the next question. So fix this picture. I will move into the next slide. Okay, so we are on question C right now. B from C, you need to find B from C. So actually C is the starting point, and B is the point of destination. So you setting up north direction right there in the point C, because you want to measure in a clockwise direction until you reach the segment BC. So where is your angle? So actually your angle, I mark as, let's say, blue one. All right, so your angle in clockwise direction from north one all around until you reach your segment BC. Okay, that's your angle. So what we're gonna do, because 256 degrees doesn't make any sense, so we're gonna use two parallel lines, and I mark them as green one. So parallel to the north direction, I set up one line, and I'm going to set up another line. So two green lines are parallel. Why I'm going to use that? Because let's have a look. We have your bearings, complete bearings, consisting of 180 degrees right there. This angle is 180 degrees. So we fixed it up. And also we need to add on top of that, to find the complete variance, to that angle we need to add a blue part right there. Okay, so from the north direction, from that segment of the line right to the segment BC. Okay, but how to measure? So we need to make sure that we are going to use two parallel lines. One more time and maybe prolong that. Okay, so and we're going to use the theorem about two parallel lines. They are parallel because they're parallel to north direction, so that's why they're parallel. We're going to use the theorem about alternate angles. Let's have a look. 128 is the angle right there. So it's the angle from one parallel line to the segment BC. So on that side, from that parallel line to the segment BC, we also have a blue angle, which is already 128. So we can say that this blue part is actually 128. So the total variance is 180. It's right there, 180 degrees, and we need to add 128. We used actually the theorem about alternate angles. They're equal, or the general idea, two parallel lines and the second line. Okay, so that's why in total we will have 308 degrees if you add them up. Okay, so C is down. Let's have a look at question D. So that's why I moved to the next slide right there. So we are on question D. Let's have a look there. We need to find variance E from C. So C is again starting point. So we set up here. We stay in here. We face in north direction. And now we turn in clockwise until we reach the segment CE. So that's why this red curvilinear arrow actually is already the variance 256. So that's why we set up the variance as 256. Okay, so let's have a look at the next question. So that this is the question E, C from E. All right. So we need to find variance C of the point C as the final point or destination point from the point E. So that's why we stay in point E and we set up north direction right there. Okay. And next we need to make a turn until we reach our segment EC. So make a turn, and that's why I mark as the blue one. So here is the variance actually until you reach the segment EC. So because C is your final point destination. So actually your course is from point E to C. So you may even draw the course if you like. Okay, so we need to find this angle. Let's set up as X. And so 20 degrees doesn't make any sense. What we can do, we can again, using the segment, two parallel lines. So I set them up using north direction. So we set up two parallel lines that go through point E and C. So right there and right here. So those two lines, one more time. So those two lines are parallel, greenish one. They go through corresponding point E and C. And now we need to find similar angle or the same angle X right there. Let's have a look here. So that's definitely angle X. We used again the theorem about alternate angles. So this angle and this angle, they're equal as alternate angles. So let's have a look now. The complete variance is actually angle X. So we set up as angle X. That's the variance. But we need to find that. Let's have a look at the figure 256. So it consists of this part, which is actually 180 degrees, and the rest part, which is X. So we can say that 180 degrees plus X will give us 256. because that's the total angle that we initially given. Okay, 256. So in total, we have that, so we can figure out x as simply the difference, 256 minus 180. Okay, if you operate, so you'll get 76 degrees if you subtract. All right, so, and the last question, F. Let's go to next slide. So we're gonna have question F. We need to find bearing E from B. So E from B. All right, so here is the point E, here is the point B. So B is the starting point because we're moving from B to E. That's our course now. And we set up north direction again, the keywords from the point. So we set up in that point north direction. And we measure the bearing until we reach the BE segment. So that's why we need to make a turn like this, okay? So that's our complete bearing. But this bearing actually consists of, again, use two parallel lines, and which are parallel to north direction. So maybe like that, it's easier. All right, so we have two parallel lines, and now we need to have a look at the angle 20 degrees. So we know the angle 20 degrees. That's basically the bearing B from E. So we are given that. So this angle 20 degrees you may find here. Let's have a look. So this small angle is also 20 degrees. So we can set up as 20 degrees right there. Okay, maybe use another color. Let's take that. So here's the small angle right there is 20 degrees. So, but complete bearings, E from B, is actually the 180 degrees up to the green line. So basically it's open angle around point B. So right there. So from north to the greenish parallel lines. Okay, that's 180. And on top of that, we need to add 20 in order to find the complete bearings, because your bearings is again as clockwise turn from north direction, where you have initial point B, up to segment BE. So right there. Okay, so that's 20 degrees angle, and 180 in total. We have 200 degrees in total. All right, so we've got that, and this is the answer to the last question. So actually this problem actually show you how to apply bearings in different ways. So like from, if you have the starting point, you move into the final point. So if you're already given that bearings, just use that. If you're not given, so in most cases actually we add 180 degrees to your initial bearings. Yes, however in the previous one, so we actually supposed to subtract. So be careful. It's not always adding 180 to your initial bearings blindly. So don't do it blindly. Okay, pay attention to actually what are you doing. Don't memorize that you always need to add 180 to your initial bearings. That might not be the case. Okay, and that actually what I said to you in the very previous starting video when I explained bearings. That might be the case when this rule 180 plus initial bearings can be broken. Okay, so be careful. Better to do one more time. It's not really hard. Just put two parallel lines and figure out alternate angles, because that's based on alternate angles theorem, and you'll get the right results. So don't lose your mark. That was Daniel Dallas, and that was the first example there. We'll go through several examples later on, so don't worry. You'll get plenty of examples in order to get bearings topic. Don't forget to subscribe if you're new, and see you later.